two questions on thermal energy and temperature. I thought to bring these up because I think these are worthwhile temperatures to let you know how temperature actually differs from thermal energy. Now, I did a video on thermal energy and I did discuss temperature, so you can certainly take a look at that, and I can put up a link up above there. But I wanted just to bring back and kind of refresh these two concepts and then give you these two particular examples. They're not necessarily quantitative, they're more qualitative examples, but they do point to two very important things when you're going to be leading on and studying the transfer of thermal energies, which basically is heat. So if you think back of thermal energy, now thermal energy in general contains two items. So it has kinetic energy of the particles that a substance is made up of, and it also has potential energy. And these two particular items constitute the total thermal energy that any substance will have or any object will have. Now, this is internal energy within it. Now, kinetic is relatively simple to understand because of the fact that it is really just the vibrations or the movement of the particles that you have. And now, temperature is actually the measure of the average kinetic energy of all of those little particles that you have. So that's a key difference. So it is an average, meaning that it takes all of the different little particles and it's capable of measuring that average. And then there are three units, typically degrees Celsius, degrees Fahrenheit, and Kelvin. And Kelvin is kind of the most ideal. It's the SI standard, and it is measuring kind of very proportional base with regards to that average kinetic energy. Now, what temperature doesn't do, it doesn't really capture this potential energy very well. So that potential energy within the actual substance is the energy that is typically stored within the bonds that you have. Now, when you're just beginning this, that's more than enough that you should know. You don't have to go that deep. You can imagine that, for example, for solids, you do have bonds that are keeping these particles kind of rigid shaped. And those bonds that are within there are the bonds and where that energy, that potential energy gets stored. So if those bonds get broken, it will release that energy, from those particular bonds. So that is the only two things. So you have kinetic and potential energy, and these are internal energies, inside of that substance. And temperature just captures typically the average kinetic energy that you have of those particles and how they're moving. So now here are the two questions. So one question goes, if you have two amounts of the same substance, so it's exactly the same, let's forget that there's maybe some differences within. Certainly, even if you do take the same substance, let's say like iron, for example, there's going to be some small subtle differences, but let's assume that they were identical. Now, one, is of mass m, and then the other is of mass 2m. So it's twice as big, so it has twice as much matter. So if you would capture this, so let's say this is 1, and this would be my m that I would have. And then I'm going to duplicate this, and, we're going to make it twice as big. So let's say this has 2m. So this would be twice as big, and then this would be just m on its own. But yet, it's exactly the same substance. If it's iron, if it's aluminum, whatever, it doesn't matter, glass or something. Now, both are at the same temperature, So both are at exactly the same temperature. Now, it doesn't matter what that temperature is. Let's call that temperature T, and they're exactly the same. Now, which one has more thermal energy and why? So this is the key distinction, and if students actually can spot the difference between thermal energy and temperature. So notice that temperature, again, going back, it measures the average kinetic energy. So if you have two substances and they're at the same temperature, sure, they can be at the same temperature because of the fact that you're just measuring the average of all of the particles. And if you have, an average, if some of them have more particles than the other, but on average they have the same, you'll have the same temperature. Now, in this case, which one is going to have more thermal energy? Well, the thermal energy is the total energy of all of those particles from kinetic, so it's not the average, but it's the total, okay, of the kinetic energy and the potential energy. So if you have a much bigger object, it doesn't have to be twice as big. It could be even by 1% or even 0.1%. So it's going to have more particles containing. So it doesn't matter that the temperatures are the same. So if T1 and T2, so if these two are the same, okay, that's fine. That's just telling us that the average kinetic energy within those substances is the same. But because one is bigger than the other, then therefore the actual thermal energy, so if you were calculating the energy, let's put a little T for thermal, so this would have been thermal energy number 2, and this would have been the total thermal energy number 1, this one is going to be bigger because it has more particles, more of them are moving around, so you're going to have more energy both from kinetic and from potential bonds. Okay, so that's number 1. So this is a really good question. And the reason why, again, is because there is more particles moving around, and there's also more particles that are bonded together. So that's the potential. All right, so those are kind of the two items. Now here's the other question that I have for you, and it states you have the same amount of two different substances. So now what we're saying is, okay, is that we have the same amount. So let me duplicate this, okay, back in here. Okay, and this is 1, and let's duplicate this, and here's the other. And now what they're saying is that we have the same amount. So meaning the masses are the same. All right, but these are two different substances. So here we have two different substances. So maybe one is iron, maybe one is aluminum, okay, or maybe one is glass or whatever. It doesn't matter, but they're just different. Now, they're still at the same temperatures. So the temperature of 1, okay, and the temperature of 2. So these two are still identical. So again, because of temperatures, this just simply means that the average kinetic energies are the same, okay, within these substances. But they're two different substances. So again, the question arises, okay, will these two have the same thermal energy? Above, we said, well, one had more because, okay, it had more matter, right? More mass. But this case, okay, they have the same amount of mass, right? So these are identical, right? But will they have a different thermal energy? Okay. Now, the thermal energy will actually be different most of the time, right? You of course, it can happen that maybe in some way, okay, because you may not be aware of what those substances are. Maybe they're close enough together, but typically they will have different thermal energies. Now, the question is again, why? So if we wanted to explain that, is that different substances, the bonds between them, and then the kinetic energies that they also have, okay, will slightly differ. So the bonds, even if we just talk about the bonds, what makes the substances different is the actual, atoms and molecules that they're made up of, and therefore the bonds in between them may be different. And if they're different, they're going to hold a different amount of the potential energy within those bonds. And then that will impact also possibly maybe the kinetic energy, okay, within them. So just because their temperatures are the same and they have the same amount, if they are different substances, they may still have, therefore, different thermal energies. Which brings me now to the conclusion here, basically saying the following, that for this case, what you will have and what you're going to be studying in particular when you're transferring the thermal energies, which is typically known as heat. So when you do that, if there are different substances, okay, then that transfer is going to happen in a different way. So the transfer of thermal energies will depend on the actual substance, okay, and we can do that experimentally and find out what that is. And number 2, it's going to depend on how much matter, how much mass do you have. So those are the 2 key things. And then the third one is, okay, this temperature, which measures the average kinetic energy, is also going to start to play a role, right? So you're going to have these temperatures, okay? What substance are you discussing? And then how much mass does it have? And those are going to be the 3 key components. All right, so that's all that I wanted to give in this particular video. I hope that it's useful, okay, for those trying to understand differences between thermal energies and temperatures within substances and different masses. Thanks for watching. Bye, everybody.